Reduction of Friction by Lubricants by Shanika Civil and Pamadita Kolamunna. Although the materials used in this experiment are relatively harmless, general laboratory practices should be followed, such as the wearing of a lab coat, safety glasses, covered shoes, and hair tied back. The area that the experiment is being performed in will need to be monitored and contained to prevent spills of lubricants. All spills should be cleaned immediately to avoid slipping. The equipment used for this experiment will be a metal tray, olive oil, stress ball worth 20 grams, and a cup. This experiment demonstrates the friction force between two objects. Friction is the force between two surfaces that prevents the surfaces from sliding across each other. This occurs as all objects have irregularities in their surface that interlock and obstruct motion. Friction forces act parallel to the surfaces and opposite to the motion of the object. Friction depends on the object and the smoothness of the surfaces. Static friction is the force that prevents objects from slipping across each other. In order for static friction to be overcome, an external force that exceeds the friction force must be applied to the object. Kinetic friction is the opposing force that acts to reduce the speed of the surfaces that are sliding across each other. Each object has a coefficient of static friction and kinetic friction. The coefficient of friction is the ratio of the force of friction between two objects and the force pushing them together. For this experiment, we propped up a metal dish on a 10-degree angle and placed one rubber object, in this case a 20-gram rubber stress ball, at the top of the tray and let go. This is a video of that experiment.
By calculating the normal force on the object at a 10-degree angle, we can determine the coefficient of static friction. We can do this by multiplying the mass of the object, the acceleration due to gravity, and cosine of the angle the pan is sitting on. In this case, the normal force is equal to 0.19 newtons. We can then calculate the coefficient of static friction by dividing the static friction force by the normal force to get 0.18. But once our lubricant, in this case olive oil, is poured on the tray and the object placed in the same position, it slides down the tray with ease. Although we cannot determine the coefficient of static friction of the object with the lubricant from this experiment, we can see physically and mathematically that the coefficient of static friction would need to be less than 0.18 in order for the static friction force to be decreased enough to be overcome by gravity.
If it were not for the lubricants that our body produces, there are many mechanisms in the human body which would produce friction. Certain fluids, for example, saliva and tears, are produced in order to minimize friction between our organs, skin, and also in between our joints to prevent deterioration.